In line with the clean aviation objectives to decarbonize the aviation sector by 2050, hydrogen is currently one of the most promising power sources. There's been a significant progress in understanding its challenges and opportunities, but still there is a question to develop knowledge about its unknowns to ensure that the novelties will not jeopardize today's safety standards. With this regard, the hydrogen proof of concept in Concerto is supporting three main pillars: the cross-fertilization of the European industry, early knowledge acquisition, and engagement with the safety regulators at the early development phases. Concerto has developed a methodology supported by the Certification Readiness Level Scale, the CRL, and this provides the aviation community with a clear understanding of the H2 aircraft certification readiness.
The Concerto journey along the CRL scale goes in three steps. First, defining the architectures, technologies, and concepts of operation to investigate and the associated level of safety. That's CRL 1 and 2, where we define a generic concept for hydrogen aircraft. Second, to characterize gaps existing in the certification regulations for large and normal category airplanes and for jet engines. For that, we define methodologies to conduct regulatory gap and risk analysis by assessing the relevance of existing regulations to address hazards coming from innovative technologies. From this analysis, we determine the critical areas for certification where regulatory and standardization developments are needed to fill the gaps. That's CRL 3. That is the backbone for the third step at CRL 4, defining orientations for rulemaking activities in these areas and for complementing our knowledge about hydrogen to elaborate the appropriate requirements and means of compliance. For example, to cover hydrogen leaks and ignition of potential hydrogen flammable atmosphere.
Hydrogen leakage characterization is an important step in fire risk prevention. The objective here at ONERA is to evaluate in a ventilated nacelle volume the diffusion of helium, a gas used as an inert substitute to hydrogen. We will identify the potential gas accumulation areas through a wide range of test conditions and in comparison with the hydrogen lower explosivity limit of 4%. Our brand new 𝘃𝗶𝘴 facility is dedicated to fire extinction and composite fire resistance in two full-scale test benches, fan and core. In Concerto Project, we focus on the fan compartment, where we develop a new system of helium injection and volume concentration measurements. This system is able to inject helium at 3 different locations for various orientation and mass flow rates. The concentrations are evaluated for 24 points distributed throughout the annular space of the compartment.
Hydrogen fire safety is a top critical area assessed within the Concerto program. It seeks to develop some standards for hydrogen fire prevention and control in aviation. A test campaign was conducted to support the definition of the future standardized hydrogen flame. We then compared the results with kerosene flames and selected suitable materials and thicknesses for fire protection strategies. First, we characterized the free hydrogen flame, measuring its length, its temperature, heat flux, and evaluating its stability. The results helped selecting which flame diameter and pressure would be used for the fire resistance test. These tests were performed on flat samples, metallic and composite, and on cylindrical bars in order to simulate a shape closer to real equipment.